Chapter 3, Section 7, the point-slope form and equations of lines. So we're going to do a couple things here. They're really just going to try to pre-solve the slope formula. They're going to do more than try to. They're going to solve the slope formula for, not really for y, but they're going to put it into a simpler form to work that out. Now here's what we're tying into is this idea of slope, and which is rise over run, or the difference of the y coordinates over the difference of the x coordinates. Now the difference that they do here, just to kind of set up the idea of this, remember when we had the slope formula before they showed us you had y sub 2 minus y sub 1, x sub 2 minus x sub 1. Notice that the sub 2 is gone, and what they're doing is setting up the idea that I'm going to know one of the points here. I'm going to have point 1. I'm going to know what those values are for this y sub 1 and x sub 1. And then if I know what the slope is, I'm going to end up with an equation with a y and an x left in it. In other words, I'm going to have an equation for the line. So what they do is, because we really haven't covered complex fractions yet, though they show us to this this process that they're going through, instead of leaving it in this form, we're going to solve it, or basically get rid of the fractions. And you can do that by multiplying by the denominator, and then you use the multiplication principle. So I can multiply anything I want on either side of this equation, but they choose this x minus x sub 1 and multiply that times both sides, because this is the denominator. And if you relate this to multiplying fractions, if I take 2 times 1/2, right, it's really going to get rid of the denominator here, or I end up with 2 over 2 times 1, and you get 1. Or if I took 2 times 3, let's say this is a 3/2, well, what I can do, because of the commutative property and the rule of multiplying fractions, is I can reorder that and put this so the numerator and the denominator are the same value, and that's equal to 1. We've defined that. If you have the same numerator and the same denominator, as long as the denominators, well, either one of them could be 0, right? So what they're doing is clearing the fractions. I have a fraction here. Well, how do I get rid of the fractions? Well, you multiply by the denominator of the one fraction we have, and you take that times both sides. So this is what they end up with. Here's the actual process of doing the multiplication, and then we end up with this form. It's really just clearing the fractions of the slope formula. So we end up with this y minus y sub 1 equals m, the slope, times x minus x sub 1. Okay? So this equation is true for x, y equals x sub 1, y sub 1. Okay? Now, what they're telling us here, and I'm going to go back, and we'll probably come back to this a little bit, and you can kind of go like, well, what are they doing this for? And, well, part of the part here is finding an equation of a line. Now, when we have a point, if I give you a point and a slope, you should be able to graph that line. You have that ordered pair, and then the slope tells me rise over run, so I go, if I have a rise of 1, I'd go up 1, and if I had a run of 2, I'd go to the right 2, and that takes me to the next point on that line of all the solutions for that equation. Well, if I don't have that equation, all I can do is graph. And graph is not a very good way to pull out all values for ordered pairs, because there's an infinity of them. If I had an equation, and I would take basically I could say if I had an equation that represented this relationship between the x and the y, or the input and the output, if we're going to get to something like functions, um, with that equation I can create any ordered pair I want. So by creating an equation, I have a better way to find solutions. And probably in a word problem, what they're going to do is they're going to say, well, I have this data point, which could be saying, the amount of bees that are around. Let's say there's 5 billion bees or whatever. That's probably a small number, too small a number, in 1990. Well, that is a ordered pair. If I think about it graphically, I would take time and I would put that on the horizontal axis here, x, and I'd put in here someplace 90, right? And then up top, probably I wouldn't have a billion lines that I go up, right? I'm probably going to write out here on the side that, hey, every one of these is 1 billion, so I'd go up 5, and that would be the ordered pair for 95, 90 comma 5, right? Well, with that ordered pair, I could possibly graph it if I had the slope, or if they gave me another ordered pair, I could find the slope. But once I have a slope and a point, I might have 2 points because I needed 2 points to figure out what the slope is. I put the 2-point data into the original slope formula, and then I have a slope. Well, this is telling us when I have a point and a slope, I can create an equation. So let's look at this. It says an equation of the form y minus y sub 1 equals m, the slope, times the quantity x minus x sub 1, is said to be written in the point slope form and has a graph that is a straight line. In other words, this is still linear. It creates linear ordered pairs, a pattern of a line for ordered pairs that are a solution to this equation. The slope of the line is m. We use that letter m, right? And the line passes through this point x sub 1, y sub 1. So if I said graph this, now if I look at this, I could pull out the data from this that I need to graph. It says that this y sub 1 is the y coordinate of the point I know, and this x sub 1 is the x coordinate. Now I need to express this or think of this in the terms of subtraction. So from this form I could pull out and say this has to be y as a negative 4 and x is 3. So I get this ordered pair of 3, negative 4. Hey, that's a point. That is a solution to this equation. Now I didn't throw the numbers in. I could throw the numbers in, put 3 in for x, and find out if negative 4 would work, right? So, but when it's in this form, I can pull this ordered pair out of that. Just like the slope-intercept form, I can pull the slope off of it, and I can also pull out a point. That point happens to be a special point, a point on the y-axis. Now this point is not the y-intercept because it is not on the y-axis. All points on the y-axis have 0 for the x-coordinate. But I also can pull out this slope. Now I have a point and a slope can I graph? And that's what they're showing here. If I go to negative 4, I'd go over from the origin to 3 away from it horizontally. The first number is horizontal change. And then the negative indicates that I go down. And I end up at negative 4 right here. So this is the point that I get out of this. Now with the slope, you got to remember with negative slopes or positive slopes, I can write this a couple different ways. And I want to write this in a useful way. Is this fraction, I want it to be a number over a number, not some negative of a number over a number. So I could write this, think of this as a -1 over +2, and that's useful as far as slope. It would mean when I'm on this point, this ordered pair that I determined from this form, I go down 1 and to the right 2. -1, +2. Now, is that the only way to get the next point or a point on this? Well, I could also think of slope -1/2 slope as a +1 over a -2. That means I would go up 1, and then over a -2 would be to the left 2. Guess what? You're going to end up on a point on this same line. Now, we don't usually see it left in this form and those kinds of things, because usually, though this is pretty good, I have ordered pairs that end up to be integers, which falls onto my grid. But I could also solve this for y, which would put it in the slope-intercept form. But you look at this, this is going to be a fractional value for where this line crosses the y-axis. I know the x-coordinate of this point right here where it crosses the y-axis is going to be 0, but it looks like, though I'm not absolutely sure, it looks like it's going to be a -2.5 for the y-coordinate, or -5/2. So this has some use. The main thing is to realize that here I can have it in this form. I can determine a non-y-intercept point from this, which is going to be valuable. Because mostly what we're going to do is take a point, and that's example 2. It says use the point slope form to find an equation of a line with a slope of 3 that passes through this point, -7, 8. So what I have now is a point and a slope. Like I said, I could graph this, but what they want is an equation of all the solutions that would be on that solution line. So we take the values that we know, slope, well, here's m, that's where the 3 goes for slope. And then I have this point, -7, 8. Well, the -7 is the x sub 1. So I end up with x minus -7, and then I put the 8 in for the y sub 1, I get y minus 8. So here is the equation for a line that goes through the point -7, 8 with a slope of 3. Okay, so we really found an equation from a point and a slope. And that's what they're talking about here too. What they're really doing in this example, they says, hey, just show me that you understand where these values will go in the point slope form. But usually the real goal of this thing is to get an equation. And usually what we want, other than standard form of an equation, which we haven't looked at for a while, which is where the x and the y terms are on the same side of the equal sign. Remember, terms are parts of an addition, and so on. So they say find an equation of a line, and most of the time, or almost all the time, we want our equation to go into the slope-intercept form, where it's solved for y. So in other words, y equals mx plus b. Slope times x plus b is the indicator of the y-intercept, which would mean it would be 0b. So here let's look at example 3. It says find an equation for the line to 8y minus 7x minus 24. Okay, and it tells us what is the slope, right? Excuse me, I read this wrong. Find the equation for a line parallel. Parallel is important here to this line that is represented by this equation, and then they give us the y-intercept for this parallel line. Well, what do I need to know, or what's the important information about this line that's parallel to the one I'm trying to get an equation for? Well, I need to know the slope. And slopes have to be the same for parallel lines. So all I need to do is then solve this for y, because then it's easy to get the slope. And notice a couple things. Well, they take 8y minus 7x minus 24. Again, a lot of people think, well, I divide 8y by 8, and if you divide 7x minus 24 by 8, it's going to be hard for you to understand where my slope is. To get into the slope-intercept form, use reciprocals. I multiply both sides by 1/8. If I take 1/8 times 8, I get 1. 1 times y is y. And then I distribute. And they say it here. Multiply both sides by 1/8. Then I need to distribute that over this two of the terms here. So I get 1/8 times 7 times x, which is 7/8 x, minus or times a negative 24, and I get 24 over 8, which is really, I wouldn't even say it that way because 24 is 8 times 3. So I get 8 over 8 times 3, which is 3. So I get this slope-intercept form. Now I would change this to an addition, because you still got to use for the slope-intercept form. If you needed it, I need that to be plus something. But in this case, I don't care what the y-intercept of this thing is. This equation has a y-intercept. It happens to be negative 3 across the y-axis at negative 3. So the point 0, negative 3 is a y-intercept. But does that help me with the other equation? They already gave me the y-intercept for this other equation that will make a parallel line to this equation. So what I need to do is only find out what the slope is. The slope of this line is 7/8. That's important. Now, what do I have to get the graph of this other line? I have a slope and a y-intercept. So I can write it using the slope-intercept form. So I'll go y equals, the slope has to be the same, so I get 7/8 x. And how do I make sure that b is right to get it? The point 0, negative 6 is go plus negative 6. There's getting a parallel line equation from getting the slope from the line that it's parallel to, because those slopes of all parallel lines are exactly the same, and then using that information to create the other equation. Now a lot of facts in there, a lot of pieces of information, a lot of things like I gotta know about slopes of parallel lines. I use this point slope form sometimes, right? Which I would rather not use because it's a little less complicated. If I have y-intercepts, I'm not going to go with that. It would work with y-intercepts. In fact, if I put that y-intercept in for the point in my point slope form, you're going to end up with something that looks a lot like this right away. But I should be able to jump right to this form because that's our shortcut for y-intercepts and slope. Now we're going to look at when they give us, we have a given slope, a point, or two given points. And I'm going to ask a couple questions up front. If I have a point and a slope, can I make an equation? Well, the point slope form will take care of that for us. If I have 2 points, can I make an equation from that? Because they're going to ask us to do that. And you got to take one step further. You got to say, well, can I find the slope with 2 points? And yes, you can with the slope formula. And then with the point slope form, I can take either one of those points, and I know what the slope is, and get an equation. So that's what's coming up here. So example 4, it says find an equation of a line perpendicular to this equation 2x plus y equals 5 that passes through this point here. Okay? Well, what do I need to know about perpendicular lines? Well, if I take the slope of a perpendicular lines and if I multiply them together, I get -1. It's pretty close to the definition of a reciprocal, but different, right? The definition of a reciprocal is when I multiply a number times its reciprocal, it equals 1. This perpendicular line slope relationship is when I take the slope of one line times the slope of another line, if it equals -1, then I have perpendicular lines, or they meet at a 90-degree angle. So that's what they're telling us here. I have a line perpendicular to. So if I find out the slope of this one, I can know or figure out what the slope of this other one line is that's perpendicular to it by understanding that relationship between the slopes. So first we solve this equation for y, and they get y equals -2x plus 5. So we know the slope is -2. So what can I take times -2 to get -1? Well, first, if I have a negative number, I'm going to have to multiply by a positive, right? And the other thing, too, to think about, if I have perpendicular lines, the slope they're saying that this is -2. As I'm in a graph right here, that means if you look at my hand here going across the screen, that means I'm going down as I go left to right. That's negative slope. Do you think a perpendicular line to this thing could be anything other than positive? It has to go up, right? So that's just kind of a note to remind you about this negativity or the negative of each other. I need to take a positive times a negative to get a -1. But if this one's negative, I know the other slope needs to be positive. So what is this slope? Well, it's going to be positive 1/2. 1/2 times -2 equals -1. And that's where they get that. They say the slope of any perpendicular line given by this 2x plus y equals 5 is the opposite of the reciprocal. Or another way to say that is if I multiply these two things together, I get -1. So substituting into the point slope form, but basically what we have now, remember what we have is I have a slope for this new line that I'm trying to get an equation for, and I also have a point. They gave us a point of 1, 3. 1, -3, excuse me. Let's go back, let's page back here. Remember they gave us this point right here. They said it passes through this point 1, -3. Well, now I know the slope that goes through this line right here. So if I wanted to graph, I could go up 1 and to the right 2 because I'm looking at a 1/2 slope. And if I wanted to graph, I could do that. Well, I can also create an equation with the point slope form. I have a point which is 1, -3. So I put those into the point slope form, and I also know the slope. So here is an equation for that perpendicular line to this one. Example 5 says use the slope-intercept form to find an equation of a line with a slope that passes through 6, -5. Okay? So we use this deal. It says since the slope of the line is 4, they told us what it is, right? I can do something here by saying, well, I know in the slope-intercept form I have y equals mx plus b. So I could go y equals 4x plus b. Now if I knew what b was, I'd be done. But I do know what a solution to this equation has to be is 6, -5. So I could take this given information and put the things that I know must be in there to make this equation true. So I can put -5 in for y and 6 in for x, and basically then have an equation with one variable that I can solve and figure out what b is. And here they say b must be -29. This is really handy too. This is just another method. Instead of using the point slope form, I can use the y-intercept form by then using the point to make sure that I solve for b, my last part of this thing that I don't know, which indicates the y-intercept. This is not the y-intercept. If it was, this would be easy, right? Is you just put in the b that was, if this was 0, -5, b would be -5. But in this case, I can put the values in for the x and y and solve for b. And then now I have what that indicates. B has to be -29. In other words, that's an indicator of my y-intercept of 0, -29, the ordered pair. But with that information, now I have a y-intercept and a slope. I put it back into the slope intercept form, and I can have an equation. So far we've gone through two different ways to write equations from points or slope and a point, right? Example 6, they say, well, let's look at this equation for a line passing through these 2 points. Now I could do this 2 ways. The way they use is a point slope form. But can I find out the slope? Yeah, I have 2 points. I just use the slope formula, which is the difference of the y-coordinates over the difference of the x-coordinates. In this case, we get -3 over -4, or 3/4 would be the simplified version of that fraction, because simplified means that there's only a common factor between the numerator and denominator is 1, which is true for 3/4. But for -3 over -4, there's also a common factor of -1. So that's not in simplest form. We could use this as slope, though. I could go down 3 and to the left 4, and it'll get me to the next point. But we just want the slope in simplest form. So they take one of the points, 3, -2, because now I have a slope, 3/4, and a point. I actually have 2 points. You just choose the point you want to use, put it in the point slope form, and you get an equation. Again, they're solving for y, because that is that's the form that it has the most use for us, and is usually the way we want to express our linear equations. There's also another reason for this. When we get into functions, or think about these things with 2 variables as being kind of like a machine where you input a value for the x and it comes out with a value for y. Well, in this form it kind of works that way. If I put 4 in for x, I get 3 minus 17/4 will equal what y is supposed to be. It's like a machine that kicks out a value for that. Sometimes they'll draw a box with a little input hole, and then you'll put in a number and it'll kick out another number after doing some operations on it. That's down the road a little bit, but that's why they like to get you to practice getting into it, solve for your vertical change, or y. So then we can also check this too. Remember, we go through a lot of steps and a lot of process, and we use points this way, and then we use 1 point this way, and all that kind of stuff. You could really start, kind of running in the trees. You got to remember what the forest is here. Is that we're trying to use slope. We need slope and we need a point. Well, if we got 2 points, I can find a slope from that, right? Keep that stuff in mind while you're doing this, or you get kind of lost in the steps. The steps, what I see with students a lot of times, if I say, here's 2 points, give me the slope. That's a question. Give me the slope. Most students will get that. Hey, I need the slope form, or I need the slope formula, right? I get a slope. Then they give us a point, like the y-intercept, and a slope. Hey, I can put that in the slope-intercept form and have an equation if that's what they're looking for. This part here where you got is kind of, you got to go to the next level and say, well, what do I need to write an equation? All the things that I'm using to write equations involve knowing the slope. Can I find the slope? Yeah, you can. And then when I have this slope, if I have a slope and a point, I've done some problems where I can write an equation for that. So that's the process we're going through and doing that. Notice they bring up this checking thing. There's a lot of math going on. There's a lot of steps. There's a lot of chances for error because there's, we've got a few things to do in one problem. It is a very good idea to check this thing. Now notice they use 3, 2 to make the equation, and they try the other point. Here's my result equation that I think I have. Well, would this point still be a solution to that? Well, I can check that. Put -1 in for x and -5 in for y and see if this is true. If it isn't, then you probably got some math error, kind of like what I do a lot of, is I probably added something wrong. And if you got good algorithmic style, that's what you need to do, is you can go through your work and hopefully check or find a math error rather than having to start all over again. Well, there's some special things that happen with horizontal and vertical lines. We've talked about that, like even when they talked about perpendicular lines where you have this opposite of the reciprocal, or the -1 times the reciprocal of each other, or the way I like to describe it is if you take the slope of a line and the slope of the other line, and when you multiply them together you get -1. That seems like the most practical definition, is you can do that. Well, when I'm multiplying slopes or dealing with comparing slopes, I got a problem when it comes to horizontal lines, because horizontal lines have no slope. Remember, it is, or excuse me, horizontal, I got it backwards, I'm sorry. Let's look at the slope. If you do something like that, you say, well, slope is rise over run. Well, how much rise is there for a horizontal line? This line, every ordered pair on here, they got one here called -1, -4. Well, I could put another one here which would be 0, -4. I could do the slope formula, but if you think about what slope means, it's rise, the amount of vertical change from one point to another, over run. In this case, for these 2 points, I told you the run is 1. But I get 0 over 1, or 0 over 5, or 0 over 4,000, right? Depending on which points I take on this. But the rise is always going to be 0. 0 divided by any number other than 0 is 0. So horizontal lines have a 0 slope. No problems there. We can compare that. Kind of hard to compare with this reciprocal thing. But what happens with vertical lines? I have all the rise I'd ever want from one point to this point would be like a rise of 4. What's my run? My run is 0. Division by 0 is undefined. I can't do this comparison of slopes. Okay? So keep that in mind as we go through these examples here. It says find an equation for the horizontal line that passes through 1, -4. Okay? Find the equation. Horizontal line right here. This is the blue line. If I graph this, this is what it looks like. Now, an equation of a horizontal line is y equals b. In other words, or another way to say that is y equals 0 times x plus b. Because isn't that the slope again? 0 times x plus b, or whatever the y coordinate is. Okay? So I can look at this and say y equals -4. And that's true. For every ordered pair, the y coordinate is -4. There's my equation. Now a vertical line is kind of like that. I have 0 times y. So I could say for whatever value, but I like looking at the ordered pairs. In this case, I have 1, -4, 1, -3, 1, -2, 1, -1, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on. What's always true is the x value, or the x part of the ordered pair, is always 1. The only way that's going to happen is I have this equation 1x equals 1. So they gave me a horizontal line and an ordered pair like this of 1, -4, and they say that through that ordered pair 1, -4, there's also a vertical line going through that. I should be able to determine the equation for both lines. Just by that one point, I can get both equations and do it because I don't have the availability to compare slopes because of this vertical line has no slope. You can't multiply by no number, right? Or null set. Now we're going to talk about interpolation, and a tool that's used a lot is, but you really got to be solid. You got to remember that, okay, now we're going to get into some applications or word problems. What is this chapter about? It's about linear equations, and it's a lot about ordered pairs, slopes, and how we write equations for this kinds of stuff. So the strategy to solve these types of equations is to write an equation. Or did I say equation? I'm saying these applications, these word problems, our strategy is to get an equation that will represent all values in this scenario that they're going to give us. Now remember, slopes are like rates, and a lot of times they'll tell us things like, you know, if I was talking about bees again, and I have 5 billion bees in 1990, that's an ordered pair. And then they said, well, in 2000 there were 4 billion bees. That's an ordered pair. I have 2 ordered pairs. Can I write an equation? Well, to write an equation, I need a point and a slope. Well, I have 2 ordered pairs. Can I get a slope? Yes. Then I have a point and a slope. I can write an equation. And then with that equation, they may say, what's going to happen in 2020 if it follows this trend? And then we're going to get into some of the words they're talking about that. Well, all I need to do is put the x value into the formula that I created, and it'll spit out the y value. That's how I solve these kinds of applications. So let's look at these types of word problems. And what they're talking about is we can estimate real life quantities that are not already known by using 2 points with known coordinates. Okay, there's my 2 points. When the unknown point is located between the 2 points, it's called interpolation. In other words, I'm trying to find out, well, I have this value from a long time ago, and then a recent value, but the question is, what happened in between those 2 points that was there? Now, I may not have the data for that, but I can interpolate, or basically say, well, if this is looking like a linear situation, I can draw a line through those 2 points, and I have all these other points in between those 2 points that I could pull ordered pairs out of, or get the data from that. It may not be absolutely true. It's an interpolation, and it's an assumption that we have a linear relationship between these two numbers. Well, let's look at example 8. Well, that's interpolation. Well, if I have 2 points, and I'm going to say I have like that B thing I was talking about. I had data from 1990 and data from 2000. Well, I had ordered pairs from those two. And then my question was, what's going to happen at 2020 based on that? That would be an extrapolation. Okay, extrapolation, if I'm saying it right. Or in other words, I'm outside of my data points that I do know the values for. It's on the outside of that. It's farther into the future in this case. That's the difference between these two words. Now example 8, apps. Here it says the number of apps downloaded onto mobile devices has increased rapidly in recent years. This increase is due entirely to the fact that more mobile devices have been purchased, which makes sense, right? As the data in the table at the left indicate the number of apps downloaded per iOS device, iPhone, iPad, or iPod. Remember iPods? It's been a while, right? Almost more than 5 years, which is like some kind of eon in the technical world, right? We could graph this data. That's what they're saying. Graph the data from October 2009 and to January 2011. Or take the ordered pairs, right? That's really another way to say that. Let X represent the number of months, which is usually we do time on a horizontal level, since October 20th. They're defining my graph, right? They're putting the scale and definition of the horizontal axis or the x-axis. And then Y, the vertical axis, is the number of apps downloaded per device. Then use the 2 points to determine an equation of a line. Well, we went through that. If I have 2 points, I can get an equation. Well, here's the data, right? And they say graph the data from October 2009. Here's October 2009, and it's 33. October 2008 is 10. Here's those ordered pairs. Now, they set up the graph the way they said describing it here, right? They said let the horizontal line represent the number of months from October 2008, right? And, let the number of months from October 2008 and Y do that. So they start out right here at 0, 0, or 0 on the x-axis is October 2008. Well, I do have a data point, or really I have a y-intercept here, right? And I would think, hey, this is nice. I have a y-intercept. But they want you to look at these 2 points and then use that. When I look at this, I would say I'm going to use y-intercept because I can graph or get an equation a lot easier from that. But let's look at the way they do this here. Right here it says, and use 2 points to determine the equation of the line. Now they do give you the choice. This is a poor choice to of ordered pairs to get this, and we'll talk about that a little bit. So let's focus in on A. I'll come back to B. It says first draw and label the horizontal axis. In other words, make sure you understand what the numbers mean, because you're going to need to know what these numbers mean later. It's not just graph this or get an equation or anything else. You're going to need to be able, if I say, well, what's going to happen 52 months from October 2008. Well, I need to know how to put that in to my equation. In other words, that's months from the origin here, the x value. So I would put 52 in for x in my equation, and it's going to spit out some kind of y value. So they talk about draw your and label your horizontal and vertical axes and start plotting some of the points. They took 12 months, which would be October 2009, right? 1 year after October 2008. And then they took 27 months, which is the last data point here, on January 2011. Now there's some pretty good reasons to take kind of a middle of the data, because these are very possibly are not going to be linear. In fact, they are not really linear. What we're trying to do is get a trend. So they take kind of the middle and the end of this data, and they take those ordered pairs. So we could graph that. Take a straight edge, put a line through that, and from the graph I could do that. Now let's look at this thing. Hey, it does work that 10 is the number of apps downloaded per device at 0, which is October 2008. But let's look at October 2009, or April, excuse me, which is, how many months is that? That is about 6 months, and or 6 or 7 months. It's kind of hard to know if that's at 25 and stuff like that. So as I'm going through this data, like I'm saying, this is real data. We think there's a linear relationship between that, and it's not exactly. But for approximation uses, right, we can create this environment. We can look at a trend that looks like there's a trend going on, and I can interpolate or extrapolate the values depending on what I want to do. So here they're going through, and then if I have 2 points, I can find a slope. I get a slope of 2. And then I take one of those points. They took 1233, and they put it in the point slope form, and hey, I end up with a formula. This is a formula of the line that goes through those 2 points. Okay? And that's what they said. I want an equation for this line that goes through those 2 data points. Now B is estimate the total number of apps downloaded per device in July 2010. Then we would substitute 21 in, which is the number of months from October 2009, for X. And in the slope-intercept equation. Well, then I get a value out. I put 2 times 21 plus 9, and I get 51. So based on this value, which is really in between October 2009 and January 2009, I got an interpolation of 51 for that value. Okay? If they ask me what's going to happen in January 2012, well, that's 39 months. On this graph, that's 39 months from 0, which is October 2008. That's 39 months. With this equation now, I could look at the graph and I could get it close, right? Looks like it's around close to 90, but not quite there. But with an equation, I'm going to spit out a number for y of 87. Now, here's the difference between, here's my 2 points that created the line here, right? These are the ordered pairs. This value right here at 21 months is interpolation because it's between these 2 data points. And this one outside, which is outside of those 2 data points, is extrapolation because it's outside. Intra or inter means inside, extra means outside. Extrapolating, okay? But there is that extra right there. That's why I mispronounced. I went extrapolation, right? But it's extrapolating is how they say it. So that is pretty useful and is used quite a bit to look at situations where you have data that has a linear pattern that we're looking at. So we can graph lines once we have 2 points. We can get equations for points or from those 2 points by getting the slope and then maybe the y-intercept, which is nice, or use the point slope form to get an equation. And when we have an equation, that's why they wanted to show that application. Is there some use for that? When I have this trend line, when I have the equation like this one here, y equals 2/3 x plus 2, I can make predictions just by putting in what's going to happen when x is 15. Well, I can put 15 or x, and I'll find out what the y value should be on this line. So I can get some data or projection on what's going on. So here's kind of a summary of the chapter here. This is a nice place to look. It kind of summarizes. There's really, we haven't introduced any new really properties of algebra. It's really about, we're going to use how to solve equations, but we're talking about patterns that we can use to help us graph, patterns that we can use to help us take points and turn them into equations. And then that last part of this section was, hey, when I do have an equation, what can I do with that? Well, I can do interpolation or extrapolation depending on where I'm falling under the data points. You got to remember, like I said, the data is going to vary. If I started with the first data point and last data point, that line might be a little bit different or have a little different slope to it too. So our values are going to vary. So there's a methodology that they showed in that example about taking middle points. Remember when I said, hey, this would be nice if I could just use this y-intercept. It's easier to make equations, but I may not get as good of interpolation or extrapolation if I do that. So again, here's a summary. We have standard form. If I have standard form, if they want us to use standard form and leave it there, we use intercepts. I put 0 in for x and figure out what y is. I put 0 in for y and I can figure out what x has to be. Those are intercepts. All values on the y-axis, the x-coordinate is 0. All values on the x-axis, the y-coordinate has to be 0. So that's a good way to figure out graphing information to do that. Like again, but graphing is not a great way to get solutions. It's really to get a visualization of the solutions, and we're going to use the formulas more directly usually. Now the slope-intercept form, if you solve for y and get it into this form, so I don't have some kind of complex fraction where I have a fraction over, or an addition over a number is a complex fraction. We haven't covered that yet, and you'll cover that in some higher level maths if you're going there. But if it's in this form, here's the slope is m, and this indicates where the y-intercept is. Okay, so if it's in this deal, I can easily say, hey, the slope's 2/3, crosses the y-axis at 0, 2. The point slope form, which is useful when I have a point and a slope and I want to get an equation, is this one. I have y minus the known y-coordinate of a point that I have equals the slope times x minus the known number from that point that I have for the x-coordinate for that. Okay, so in this case I would have the point 3, 4 with the slope of 2/3. I can write this equation. Okay, and that's the end of this section, and that's actually the end of the chapter. And so we're into testing and quizzing first, and then we'll have chapter tests.